Hello everyone, today class number 31 for electrical machine 2. Class number 31 for electrical machine 2. So today I will start the new topic or new module called synchronous machine. Synchronous machine. New module called synchronous machine. Okay. So before start the synchronous machine, I would like to express that what do you mean by the term synchronous? Synchronous means when the speed of the motor or the rotor, the speed of the rotor is exactly equal to the synchronous speed. Okay, so this synchronous term refer the speed of the rotor equals to synchronous speed. So what is synchronous speed? Synchronous speed is nothing but ns equals to 120 fs by p, right? This is your synchronous speed. 120 fs by p, this synchronous speed. So when the rotor speed will be equals to ns equals to 120 fs by p, then the machine is called synchronous speed. Okay, so one question is that induction, in case of induction machine, there is a ns called synchronous speed and nr called rotor speed. Okay, so this is induction machine can act as a synchronous machine when ns equals to nr. Okay, so what do you mean by this significance? Ns equals to nr, that is rotor speed of the armature or the rotor section of the induction machine will be equals to ns. Okay, that is synchronous speed. So at this situation, slip equals to how much? Slip will be 0 because slip equals to ns minus nr divided by ns. Okay, so when nr equals to ns, then it will be 0, right? So at synchronous, that for synchronous machine, our conclusion of this discussion that for synchronous machine slip equals to s equals to 0. Okay, so this is all about the synchronous machine, the term synchronous concept. Okay, so now the synchronous machine classification. So synchronous machine can be classified into two categories. There are two categories of synchronous machine. Okay, first one is alternator and second one is three-phase synchronous motor. Okay, so alternator means you can write three-phase synchronous generator, three-phase alternator or three-phase synchronous generator. Okay, so what is alternator? What is synchronous generator works? Right, I would like to start the alternator first, then after completing the alternator I will move into the three-phase synchronous motor. Okay, so this total module required at least 15 or 16 classes. Okay, so today is the class number 1 for your synchronous machine concept. So first write some point regarding the alternator. Okay, first write some points regarding alternator. Okay, right, for alternator, right, for alternator stator, for alternator stator windings are three-phase distributed type. Three-phase distributed type. Stator windings are three-phase distributed type and the rotor windings are distributed or concentrated. What? Or concentrated. Okay, so for distributed rotor winding, used in, alright, distributed rotor winding used in cylindrical rotor alternator. Cylindrical rotor alternator. So alternator rotor, there are two types of alternator rotor. Okay, there are two types of rotor used in alternator. So first one is cylindrical rotor, where the distributed winding or distributed rotor windings are generally installed. Okay, and next, for this concentrated part, for concentrated rotor winding used in salient pole rotor alternator. Salient, S-A-L-I-E-N-T, salient pole rotor alternator. Okay, so there are second type of rotor of used in alternator. Okay, so one most important point, right? Stator of alternator equals to armature. Okay, stator is called, or armature is taken as stator, and rotor is taken, or rotor in belongs to field. Okay, field system. So here one most important difference. Okay, so most important difference from the induction motor, that is, for induction motor stator equals to field system and rotor equals to armature system. Okay, but for this case, stator, armature is installed in stator and the field system is installed in rotor. Okay, for your synchronous machine. So for synchronous machine, this uniqueness is used in as per the construction. Okay, in the construction of the synchronous machine. Okay, so next, right, point wise, next, right, alternator is called right here, alternator is called doubly excited machine. Doubly excited machine, due to presence of, why it is doubly excited, it is called doubly excited, right? Due to presence of two sources of power. Due to presence of two sources of power. So in case of alternator, alternator required two sources of power. Okay, one is electrical and another is mechanical. Mechanical energy is given by the prime mover, okay, to the rotor part, and simultaneously there will be an excitation system required to excite the field. Okay, so that's why it is called doubly excited machine. Okay, and second one, right, and next one, right, field winding is powered by a DC voltage source. Field winding is powered by a DC voltage source. Okay, and rotor, that is field, is rotated by mechanical energy by prime mover. Okay, what is prime mover? I think all of you are very much clear, or it is very much familiar to you. What do you mean by the prime mover? Okay, prime mover means the system which makes the rotor moves. Okay, which makes the rotor to move. Okay, so these two systems, that's why it is called double excited system. Okay, so next, right, to generate, next point, to generate three-phase power in any three-phase alternator, the three-phase armature winding can be either stationary. The three-phase armature winding can be either stationary or the field system is rotating. That is, there are two types of possibilities to generate the three-phase balanced power. First possibility is, right, can be either stationary, that is armature winding either stationary and the field system is rotating, or three-phase armature is rotating and the field system is stationary. So either armature is rotates or field is stationary, or field is rotates and armature is stationary. But here I have been discussed that stator is called the armature, so armature is stationary, and field system is rotating. Okay, so this arrangement makes a advantage. Okay, so this arrangement makes a advantage in synchronous machine. Okay, so you have to discuss that this concept, why the armature is taken as stator and the field system is taken as rotor. Okay, so our next topic is, this is also the basics for the alternator. Okay, right. The advantages of installing field winding on the rotor. So what is the advantage, or what are the advantage of installing the field winding on the rotor? Okay, so write some point. First, write for economical factor. So write, in an alternator, the armature power rating is very high. In an alternator, the armature power rating is very high compared to field winding. So as the armature power rating is very high compared to field winding, so if the armature winding is placed, on the rotor, more insulation would be required. So more insulation would be required if we produce if you place the armature inside as a rotor. Okay, so and more insulation costs more. So that's why from the economical point of view, it is beneficial to put a field system as a rotor and to make a armature as a stator part. Okay, so first point is for economical factor, and second point, easy to maintain. Right, the armature winding is more heavier. And complex compared to field winding. So armature winding is more heavier and complex than the field winding. So if the armature winding would be placed on the rotor, there will be a maintenance problem. As such, field winding is placed due to less maintenance. Right? As such, the field winding is placed due to less maintenance. So due to the less maintenance, the field winding is installed as a rotor. Okay. Due to the complexity of the armature and the armature is a large enough to place as a rotor. Okay. So next, write third point, more efficient. Okay, right. If the armature winding is placed on the rotor, then the generating power from the armature winding. So if the armature winding is placed on the rotor, then generating power from the armature winding will be collected through brush and slip ring arrangement. So when the armature is placed in rotor part, then the collection system should have consists of brush and slip ring. Okay, so there will be a I square R loss at the brush and slip ring contacts. So there will be a I square R loss in at the brush and slip ring contact, and also windage and friction loss. So at the brush contact will be increased. So at the brush contact there will be a friction and windage loss, and there will be a I square R loss. Okay, this type of losses will be carried out if we place the rotor part in as a armature. Okay, or armature as a rotor. Okay, so if the field system is placed on the rotor, so if the field system is placed on the rotor and the armature system is on the stator, then the collection system, that is the whole generation system, will be more efficient, as there is a reduced loss, reduced I square R loss and friction and windage loss. Okay, so alternator is more efficient for installing the field winding on the rotor. Okay, so it is more efficient will be. Okay, so last one, the fourth point, less torque by weight ratio, less T by W ratio, that is torque by weight ratio, right? Since the armature system is heavier than the field system, so if the armature system is placed on the rotor, it will increase rotor inertia. So if we place the rotor as the armature, then it will increase the rotor inertia. Okay, it will increase the rotor inertia. Thus, the torque versus weight ratio will decrease. As the armature weight is increased, the torque versus weight ratio will be decreased. So if the field winding is placed on the rotor, then the torque versus weight ratio will increase due to less rotor inertia. So if we placed the rotor part as a field, then the torque versus weight ratio will be increased, as the weight of the field system is less than the weight of the armature system. Okay, so that's because this concept, torque versus weight ratio, will be increased by putting the field system as a rotor. Okay, so EMF will be maintained. So the generated EMF will be maintained at the rotated value. So what is the significance of this torque versus weight ratio increment? So if the torque versus weight ratio is increased, then the rated EMF will be maintained at the rotor portion. Okay, so now this is the second topic. So now I will move into the third one. Okay, so this third one is nothing but the excitation system. So every field system requires some excitation, right? Every field system requires some excitation to produce a field flux. So there will be three types of excitation system. So write excitation system of synchronous machine, or within bracket you can say alternator also. Alternator needs some excitation, okay, to the field system, right? Exciter is a, what is exciter? First write the definition of exciter. Exciter is a electrical arrangement to provide DC excitation for field winding, Okay, so there are three types of excitation systems are present for synchronous machine. First one, write DC exciter. So you have, for this case you have to draw it and you have to make understand by yourself. Okay, so what is the working principle of this DC exciter? See, the DC exciter need first generator. Okay, it needs some DC generator. So this DC generator will generate. So this DC generator is nothing but the shunt field generator. Okay, so this is a shunt field generator. So this DC generator output will be connected by a inductor. Okay, so this is a generator, DC shunt generator, and this resistance is a variable resistance, suppose R1, and this is the field R of F1, that is this generator field. Okay, shunt field. Okay, so this generator will produces a current, suppose IL1 to this, or alternating to this conductor. Okay, or to this inductor. Okay, so this inductor is nothing but the main field winding. Okay, so it is for separately excited DC generator. Okay, this is for separately excited DC generator. So this is your DC shunt generator, and this section separately excited DC generator via a okay. This is brush and slip ring. Okay, this is brush and slip ring. So make it change. So this is, suppose this is positive brush and negative brush. Okay, so this is R2. So this is your DC separately excited DC generator, separately excited DC generator. Okay, DC separately excited DC generator, and this is two slip ring, positive and negative, and this one is main field for 3-phase synchronous generator, and this is the field system. Okay, so this field system, so DC generator will provide some mechanical energy T into omega. It will rotate and it will generate a current to produce this field, right? This is your RF. Okay, so this is your RF. Suppose this is RF1, this is RF2, and this field, due to this field, this separately excited DC generator is induced. Okay, so this generator and this generator are coupled by a common shaft. Okay, this generator and this generator are coupled by a, this is the coupling sign, coupled by a common shaft. Okay, and this is the rotor part, and after that the rotor part of the 3-phase alternator. Okay, so prime mover will rotate this DC generator, and simultaneously this separately excited DC generator also. Okay, so this one induce an current to this field. This field will operate this generator, so that, and by controlling this R1 and R2 we can change the excitation to this main field for the 3-phase synchronous generator. Okay, so after that it will produce a magnetic field to the air gap, and which is rotating in nature, and ultimately the rotor will rotor will rotate. Okay, so simultaneously the rotor will rotate. Okay, so this is the excitation system for synchronous machine, and this excitation system is DC exciter, as there are two DC generators are there. Okay, so next one. So right, this system is less efficient, okay, compared to other types. Okay, because what is the reason? Because there is no feedback control signal. There is no feedback control system is present. There is no feedback control system is present. Okay, so second one, type 2. So type 2 excitation system is called static exciter. Okay, so in this case, an SCR means thyristor. SCR means silicon control rectifier. Okay? This is the sign of the SCR. Okay, so this SCR will be induced by a DC supply. This is double pole double throw switch. Okay, this is double pole double throw switch, and it will be connected, suppose positive minus, negative positive positive, negative negative. Okay, so it will be connected to here, and after that it will be so from here actually is the rotor. This is main armature field. Armature winding, main armature winding. Okay. And due to this two phase concept, it will be a feedback control, right? It will be a feedback control. And through this current coil, it will be triggered. Okay, there will be a triggering system through some regulator. Okay, through some regulator. Okay, so this is a transformer, step down transformer. Okay, see what happened. A 120 volt, so it will be rated by 120 volt DC battery bank. Okay, DC battery bank. So through this DC battery bank, the thyristor will be triggered and thyristor will be turned on, and from here it will be through some slip ring and brush arrangement, the armature excitation will be excited. Okay, so this thyristor will be controlled by controlling actually two operations. So this voltage, so voltage reading from the armature, from the rotor part, that is field part of the alternator, and the current flowing through this output, which will be regulated by a regulator, and it will be triggered by this concept. Okay, so by this way it will be triggered, and simultaneously the main armature field will generate a flux to rotate the rotor part. Okay, so as the rotor is rotating, so this regulator and step-down transformer are actuating, so the thyristor will be triggered when it is required. Okay, so this is the feedback control path. Right? So for the static exciter system, it is efficient. It is very much efficient, as it has a feedback control path. This exists present. Okay, so and last one is brushless exciter system, which will be taught in the next class. So today's class up to this much, as the time is completed, time is over. So in the next class I will start the third type of excitation system, that is brushless excitation system. Okay, so thank you. Today's class up to this much.